Okay, so I set it in the vise low enough with just something to hold the back of it set up on the line, so that when you push this in, glove on, and push this in, it runs along the edge of the vise jaws. So you line up on the first where you want to put the first hole, put it in, it gives you a slot. It's not perfect, but then you can file it out. That one's better than the first one. So in this one, start there, a bit of time, till it's the right length, 20mm long we're doing. Okay, MIG Braze in. So first off, you've got to make sure that you've got pure shield argon. So if you look at that cylinder, it's all one colour. That's an argon cylinder. If you look at that one, that's two different colours. So that's a mixture of argon and CO2. If you just changed it, make sure this is all tight. You should also put some water with a little bit of soap in it around here just to make sure it's not leaking if you just change the cylinder. So turn the cylinder on slowly. It wants to have about half a turn turned on. Gauge on the left is your content gauge, tells you how much is in the cylinder. Notice it's called a cylinder, not a bottle, especially for exams. PSI and bar, so it's shown on the outside as 100 bar. So as you can see, that's 100 bar at 14.7 psi to a bar would be 147,470 psi. You get it right? Okay, so I turned it on. You can see the content gauge. You can see the flow regulator is on the other side. So with it just running, as I pull the trigger, you can see that the actual flow when it's triggered and the flow when it isn't are different. So you have to adjust it for when it is triggered. So it's a little bit high at the moment. I want it to be about 12, so I don't use too much gas. So it's a little bit too little. Tiny bit more. I'll go for about that. That's probably about 14. Okay. Okay, so setting the machine up. On here, this is your pulse like spot delay, so that'll give you, when you pull the trigger, it will weld, not weld, yeah. So we don't want to mess around with that one. Wire size is on here, and the type of welding is on this one. So at the moment it's up in here, which is manual, so it's avoiding all this. At the moment we've got the copper silicon wire in there. So we bring it up onto copper silicon. You could have a look inside and check, but it's 1mm, so that's the correct setting. Optimal wire speed is normally between here, because it's synergic, it sort of does the wire speed for itself. This wants to be on 0. This is your spot delay, so if that was on, this would give you your delay. And then this is your step up, as you can see, 1, 2, 3, 4, 5, 6, 7, 1 being the lowest power setting, 7 being the highest. So always put it on here on number 1, put it about in the center, and try it out on a piece of scrap, see what happens. Okay, for the gun, cut off any excess wire. Now you can see that's all wobbly, that's no good. So we turn it and turn it clockwise and pull it off. We're going to check this, it's got a little bit of spatter on it. Flick it off. Make sure this is tight. If that isn't tight, use the proper little set of grips from inside the thing and just tighten it up a little bit. So I'll just use a pair of grips I've got here, like that. That's tight. If there's any rubbish inside the nozzle, you can use this wonderful multi-tool and just give it a little flick around, flick any little bits of spatter off. It's hard to keep it all on the video, I'm afraid, sorry, because I'm doing it on my own. Twist it clockwise to go back on. Push it all the way on and try and get it so it doesn't wobble too much. Probably needs another tip on that one. Okay, so that's that part. Also, connect. I'm welding on this table, not on the normal one. So connect your return lead, not called an earth, to the actual table or to the job. Check that this is all intact and tight, because if this is loose, it causes arcing across here. That makes that heat up. This will eventually melt the cables where they get hot, cold, and it will cause a problem with the circuit. Yeah. So connect that to the table you're going to be using, like that. Okay, so we've got some metal cut up with the slots, and we've got some steel without any slots at all. Got a little jig here for doing, you can use it for doing the lap and the butt. At the moment I'll just put that in there for a butt. You can see by clamping it this way, it holds it nice and flush, and you can get a gap if you need one, really tiny gap if you're going to try and use one, of normally 1 millimetre to allow the penetration. First of all, before I do that, I'm going to test weld it on a piece of steel, just to make sure the settings are good. Okay, so I've got a piece of steel. I'm just going to cut off any extra. Make all the gas coming out. Quite high angle. So here it's spatter a little bit. So I wouldn't say that's the best setting in the world. What you also got to remember is you're trying, if this was a normal MIG welder, mag welder, depending on the gas set. So MIG is metal inert gas, mag is metal active gas. So the active gas is the CO2 argon mixture, which has an effect on the temperature range of the weld and things like that. Anyway. You're aiming to keep the heat input on this to around only 950. Normal mag welding is probably about 1400. So the whole point of this is to keep the heat low and don't overheat high strength steels and things like that. So to me, that's a little bit, you do welding a little bit quicker, a little bit less heat input. But that is on setting number 1. So can only really alter the wire speed. Okay, so what I'm going to do is I'm going to put a tack on the end I'm welding towards. And then start. Going quite well until the machine messing up. No penetration at all, as you can see. What I need to do is leave a gap a little bit slower. So I'll set that up and then we'll go again. clamps on it, see if it can hold it down a bit better. And try pulsing it. It's got a good bit at the beginning. Very good. So that was a good example of why you do weld tests on cars. Because you need to make sure that you've got the right setting, the right gap, the right speed, everything like that before you actually do the car. Felt slightly nicer. Heat affected zone is nice and small, which is always the important thing, because the least that you can get. Right, so it's got some penetration. The middle is good. The start and stop aren't that brilliant. So one more, slightly bigger gap. So with any test weld, you can cut off the first 25mm, I think it is. Measure the middle. So that bit, it's great. Tiny gap there, and that bit isn't quite as good. But you can see it went a little bit too fast, carried away. Spattered a bit there because it had a bit of dirt in it. Okay, so I took some photos. Trying to clamp the two pieces of metal together. That's why I've got this second piece here, so it sits level with this over the gap in the little jig, just so that it doesn't sort of soak all the heat up. So the idea, we've got them clamped. What we could do is put another clamp here and here, just to hold them nice and square, but we'll try it and see what goes on. So it doesn't look too bad. What you do is start on one side of the hole and you zigzag around and do a circle at the end. I'll do the next one. And the only real way to tell if these are any good is to do a cup test or sand them off. Okay, going to do a couple more cup tests, or destructive tests. This one hardly got any penetration on the butt weld. Feel. Pass. And the lap. That's fine. Pass. A couple more I did there. So there's a butt with a bit of penetration. Pass. Fail. First one setting up, no penetration at all. Two taps, split straight away. We got the one what did pump it came through massive amount. Split eventually in the heat affected zone either side, which is where it should go. I hit that a lot.